One of my favorite planets is Kepler 10b. This is a super-Earth. It's a rocky planet, a few times the mass of Earth. And actually, you know what? This planet has an orbital period of less than 1 day, 0.85 days. And it's so close to its sun-like star, by Kepler's law, it's very, very close to the star. It's 20 times closer to its star than Mercury is to our sun. We know planets didn't form that close to the star because there's just not enough material. So planet migration, how planets interact with the gas and the other planetesimals in the disk and migrate through, and how they stop and not fall into their star is another big open question in planetary physics. And this planet is so hot because it's so close to the star that we imagine the planet is hot enough so that the surface is hot enough to melt rock. And so the liquid lava would be there, not because of any tidal interactions or volcanoes, but just because the surface is heated so much. Now, most of our planets, here's Gliese 1214b, we don't even really have enough information to speculate on what might be going on that planet. And here you see with the artist's conception, the artist, I think, always shows some nebulosity because planets sometimes are not necessarily that interesting. But here, for this particular planet, we have a mass and a size, and it's what we like to call these ones a mini Neptune. It's one of those 2.5 times the size of Earth, one of those most common types of planets out there. And this one's somewhat close to the star. Its temperature and its atmosphere may be about 700 Kelvin. Now, I chose this one to tell you about what we work on exoplanets. So this is a kind of an unfortunate case because this particular planet has a mass and size and average density such that we don't actually know what the planet's made of. It could be, if you look on the far right, a rocky planet with a massive rocky core surrounded by hydrogen atmosphere. All planets, even Earth, was born with hydrogen in its atmosphere from outgassing of the planet-forming material. And so alternatively, this could be a new type of planet we speculate about, a water world, shown on the far left. And a water planet you could imagine as like a scaled-up version of one of Jupiter's icy moons, 50% water or more by mass. And in this particular case, the planet being about 700 Kelvin in its atmosphere, it could have a thick steam atmosphere overlaying an ocean, not of liquid water, but the temperatures and pressures are such that it could have a layer of superfluid water. Here on Earth, the only place where superfluid water is naturally occurring is at the deep sea vents under the oceans. And in this particular case, there'd also be high-pressure hot ices on the inside, like Ice 7 or something like that. So actually, some areas of exoplanets, despite having precision measurements in the mass and the size, we get to a dead end. We really can't say anything else. We could quantify all the possibilities of what the planet is made of, assuming that it's spherically symmetric and differentiated, meaning the denser materials on the inside. And often we just have to leave it at that.